Hello. I've been asked to show how to build these capacitor switching boards because they're particularly useful in getting resonance out of strange scenarios with tester coils with rods down them attached to rodent coils. So they're very useful for changing capacitance within the actual coils themselves when they're resonating. Yeah. Where did that happen? Shit. Weird. All right. Well, that's just an example of what happens. Sometimes it throws a bit of a wobbly. That's about 2.3 kilovolts there, and it's given a frequency is about 124.6 kilocycles. It kind of likes that, 124, 125. But you can get it from so many different combinations of capacitive loading. It's very strange. And it'll disappear, and then you'll put some in and it'll come back, or then you'll take some out and it'll drop down, and then you take some more out and it goes shooting up. So it's very strange. Anyway, but it's useful to get it. I've got a discharge. This is just DC low power, 12 volts going in. So got a bit of a discharge there, but I'm just running another experiment at the same time. So anyway, so that's basically what they're used for. I've got two here in parallel, and obviously in parallel with the ZVS board. And so because I just ran out on this and I had to put another one in to start be able to manipulate that as well. And that's what they're useful for. It's great. You've got 2000 volt capacitors everywhere here, which is fine for parallel resonance. But if you're going serious with series resonance with this stuff, I've got 6 kilovolt versions of it. And rather than switches, you need little jumper cables to go in between the green terminal posts. But anyway, I'll show you how to basically make a board. Okay, so I've laid out. I ordered a bunch more capacitors. I should have checked the pin distance because the MKP-10s are basically like these, those are 22 nanofarads, whereas these are 2.2. So you can see the footprint is much larger if you get FKP ones instead. But I basically got what they had in stock and thought I would just crack on and get it done anyway. So yeah, I've got a couple of 47s, 22s, 10s here, then smaller down to singles, and then 100 picofarads down at the bottom here, just to try and cover everything. So there's 336 nanofarads total on this board. Basically, this perf board is there's no metal on it at all, and that's better for high voltages. Also, credit where it's due, this is actually a Master Ivo design. He came up with this maybe about 4 years ago, and I saw it and thought, well, that's brilliant, perfect for what I needed, and I've been using them ever since. So thank you, Master Ivo. So basically, I've laid them out and I've put just marked out where I'm going to put these switches. They've got a reasonably small footprint, so I'm going to just put them in like that, and the switches protrude enough so you can actually get to them. It's a bit crowded in this board. There's going to be like 40 switches on it, but I've only got 30, so I've ordered another 10 just to have enough to get it all done. But anyway, so 6mm drill bit seems to make the right hole size for these switches. And yeah, these are single throw, double pole, something like that, STDP. And yeah, so I'll just crack on and I'll get the rest of the holes built, install all the switches, and then I'll take a look at how to wire it up at the back. Okay, thanks. All right, hello again. That's a rather dull task of putting all these switches in. I'm still waiting. I've got 10 switches missing here, but I've been cracking on anyway. Yeah, these stands are really useful for doing things like this. You can spin it over. The common traces, I've put those in. These are the, I mean, it's obviously it's not polarized, but if you put all the feet that are together away from the switches into a common line, then that will then work as this one works across here and across the back here. So it covers all the switches and the switches to go in. Then you can feed the end result of that back to the terminal posts, which will be in the other side. I'm not putting those in until I get these switches in, and then I'll put them on the outside. But as you can see, I've just traced out the lines that made most sense for it. You've got all the single inputs here marked in red toward the switch that they're going to go to. And I want them all to switch on in the same direction. So some of these will come across to the actual activating pin here on the far side, whereas these are simpler because they're just going straight to the top because of where they are in orientation to the switch. But that's basically it. The common line that goes through the center of the switches is obviously for the other side of the capacitors, which is being switched. So they're being switched in and out in parallel. And this is the other side, which is just constantly on, going to the other input to the capacitor board. So again, we've got the one common to the pin that is parallel in all of the capacitors, and the other side of the capacitor is in parallel but with a switch on it to switch it in and out of the circuit itself. So all of these need a separate little wire going to each of the single switch inputs, which are then switchable on and off to add them and take them out of the circuit. Okay, so I'll update when that's finished as well. Thanks. Okay, so I've got all the little white wires are the other leg, the remaining leg of each capacitor being connected through to the switch. And so I've got all the wires connected for all the switches that I have. Still obviously missing those 10, but this is getting it into a usable state. So it'll be quick and easy once I get the other switches in. So I'm just going to test it out and make sure everything is going as it should. Just connect the multimeter here to the two lines of the capacitor so that everything is switched off, all the switches in the down. I wanted them oriented one direction. Stop confusing myself. And okay, so that's on. That's a 47. It's showing 44.5. There's another one, which is 44.5 again. And I've been through all of these and everything works fine. All right, so, yep, cool. If anybody needs a schematic, I could give one, but it's really straightforward. And you see the way the switches are connected here. I oriented all the switches the same way up. So I think the writing was on, looking at it like this, the writing on the switch body was on the right-hand side. So that always meant that putting it up is going to switch it on and down is off. So that's how all the switches are configured. And to maintain that integrity, I just put a little red dot on the top on the two parts of each switch that are active, so it didn't tempt me to go straight from here to that leg, and then that would reverse the switching. So just something to look out for. Any other tips in this? Yeah, I tend to, when just putting these wires together, is just cut them all first of all, and then just using the tweezers here, I'll actually bend the wire around like that. Oops. Ow. And then just hook it on, guide it round where I want with the other end off, make another circle on that, and then just wind it around the leg of the capacitor, tighten them up at top and bottom, and then go on to the next one, and then just solder them all as a one one thing. So there we go. Yeah, again, just to reiterate, one leg of every capacitor is on a common line, so they're all connected essentially in parallel, but the other leg is switched in and out of that parallel circuit. Simple as that. It's really straightforward. Time consuming, but very useful. All right. I hope that helps, and thanks for taking the time to watch. Thanks very much.